Hello, everyone. Good afternoon, good evening. Dear authors and invited guests, welcome to technical session 6E. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the 10th International Congress on Information and Communication Technology, ICICT 2025. London, United Kingdom. The 10th edition of this conference has been organized in a hybrid mode. The physical event was held in London yesterday, and the virtual event is being held through Zoom platform. Um, that is from 19th of February to 21st of February. I hope you will enjoy the knowledgeable interactive sessions throughout the day. In this session, we have 6 presenters. Each presenter will be getting 12 minutes for their presentation and 3 minutes for question and answers. On 10 minutes, I will just raise a gentle reminder. I also request all the participants to stay connected with us till the closing remarks. And if you have any query or update, you can write to me in the chat box. Just a minute. Just before we start the session, I would like to introduce to our session chair, Dr. Kirit Modi. I welcome you, sir. Professor Kirit J. Modi is currently working as a professor and head at CE and IT department, IQAC coordinator at Sankar Chand Patel College of Engineering and Dean at Faculty of Computer Science, Sankar Chand Patel University. He has more than 20 years of teaching experience. He has published more than 25 research papers in the reputed international conferences, referred journals. He has served as a member of editorial board and program committees of international conferences and journals in text and web of science and Scopus. I welcome you, sir.
Yeah, thank you, Deepika,
Thank you,
for
sir.
nice the introduction. Yeah,
Yes, sir. Thank you so much. As requested by David, I would like to, let him allow for the presentation now. Yes, sir. You are presenting a paper on evaluating the scalability and suitability of deep learning models for energy consumption forecasting in smart homes. Yes, sir. You can start sharing your screen.
All right, thank you
Hello.
very
Yeah.
much. Yes, thank you very much. I am going to share my screen in a second.
Yes, sir. Yes, sir.
Go. Okay. I hope everybody can see my screen.
Yes, sir. We can see your screen.
Awesome. Thank you very much. Good afternoon from Cape Town. My name is David Atipo, and I am with my colleagues. We are from the Center for Augmented Intelligence at the University of South Africa. And this paper is titled Evaluating the Scalability and Suitability of Deep Learning Models for Energy Consumption Forecasting in Smart Homes. So the presentation overview, I'm basically going to give an introduction and a motivation, and also present the methodology and the data set that was considered for this work. I'll also give a very, very brief description of the DL models that we use, and then I'll talk about some of the performance metrics and the results that we got, limitations of the work, conclusion, and the future work. Global demand of energy has always been on the rise, especially as recorded by the World Energy Organization, which is the body that records these kinds of activities. Was looking at the fact that residential and commercial buildings typically account for approximately 30% of overall energy usage globally. In recent years, we've had a very huge surge of the adoption of Internet of Things within homes of individuals and also within commercial buildings. And these IoT devices do generate large sums of data which most individuals use for monitoring and control, as well as overall management of the buildings. Unfortunately, most of these data sets are proprietary and not readily available on open source databases. It obviously does present a challenge where the data that is even available is limited to data coming from, sensors from single buildings or, complexes. And so research around, smart data IoT for predicting energy consumption really does sit around, complexes and single, buildings and so on. And that presents a very big challenge because of the fact that we are not able to capture the complex usage that could persist within, trying to predict, efficiency in the energy usage across, 4, 5, 10 homes, 20 homes, which could obviously comprise either a small town or even a city, as we might call it. So the primary goal of this work is primarily to evaluate the scalability and performance of, certain, DL models like LSTM, GRU, and ANN for, short-term energy consumption forecasting. And why we're choosing deep learning primarily is because we know very well that deep learning models handle effectively large scale data. They capture temporal and behavioral data that exists within the data set, and then on top of it, we don't lose any accuracy while doing all of that. With regards to scalability, it becomes very, very important when you are deploying a DL model. Scalability becomes an issue. And so one would definitely love to look at the combination so that as the data is increasing, in cases where the data is available, of course, one can combine that effectively. So the specific objectives of this presentation now will look at, comparing the model accuracies with regards to MAE, RMSE, and then, of course, the R squared. Access also we want to also assess this scalability of 20 to about 200 homes, and then also evaluate training and inference times just to be able to understand which of the models are rigorous in predicting and also whether or not they have a sort of stability across board. So the methodology and data sets. So the data composition, primarily because of the lack of the data, we had a very small sample set of data that was used to then synthesize more data. And the synthesis, process is detailed in our document. However, we looked at the synthetic data for like 20, 50, 100, and 200 homes. The information primarily also included, weather conditions from, Saudi Arabia, northern Saudi Arabia. And the idea was because the original data came from there. And so we needed to look at, the weather conditions over the year. And then we were able to also do the synthesization of the data for us to be able to do that. However, when we looked at, at the end of the day, when we looked at the 200 home data set, we saw a very big, frequency in the distribution across board. And so we needed to look at what the overall data would do for us. And we came to the notion that the best idea would be then to look at, if you look at, the average daily consumption, the minimum consumption and maximum consumption, there's a very big variance in there. So how do we then look at it? So a very simple approach was then to look at the mean consumption versus the individual homes. And that was what we used for our data set. And so for the prediction framework, like I said, our target was primarily to look at the mean daily, consumption. And this framework, as I said, we propose a prediction framework that focuses on forecasting the average, energy consumption over the year rather than predicting the individuals because of the variance that existed in the data. And then also, the approach actually simplified the modeling complexity and also yielded a broader insight for city level energy planning, which is something that we obviously wanted to look at. So with this approach, we can effectively scale a more generalized model to array data sets, representing different number of smart homes. So we can look at, 20, 50, 100, and so on. So this was the equation that was used. And like I said, when you look at now the mean consumption over the overall, then we are able to now do a very good prediction. The DL models that were recommended, that we chose here, were the artificial neural network. And as we all know, with the multi hidden layers that are there in the MLP. We also understand the easy and very quick way of implementing this. And then also the only challenge with the cons is that we are not able to understand to a very large extent the temporal, deeper temporal patterns that may exist in the data set. However, ANN models have been proven to be very, very efficient over the years. Also, we looked at the long short-term memory, the LSTM, and as a specialized RNN with memory cells, it is able to capture long-range dependencies, which is something that we were also looking for. And then also, with regards to how the data was distributed, we wanted to also look at GNN, which also as a RNN was able to process much quicker because of the fewer parameters that it considers rather as compared to the LSTM. And so, of course, one would look at these kinds of models as the key models that we can use. In the literature review, we realized that these were the optimal models that one could adopt in these kinds of instances as compared to traditional time series models. With regards to the model evaluation, we considered the root mean squared error. We also considered the absolute mean error, and then also, like I said, the coefficients of determination. These are represented mathematically as below. And sorry. And in summary, we were the ML models that we used in terms of the deep learning models accurately predicted the mean consumption in this 200 smart homes for 20 days. So we looked at that to be able to give a very good justification to how well the models work. And indeed, they proved to be very, very efficient. So that was a very first stage to how the work, how the models were able to effectively predict. However, now we wanted to understand how are the models performing, at each home. So we looked at, for example, performance comparison of the ANN for the mean energy consumption prediction in different smart home data sets. So we looked at the 20 smart home data set, which gave us, data for each home for the year. And as can be seen clearly, ANN did very, very well in predicting with a very low MAE at even 20 smart home data set. 200 smart home data set. And also when you look at the 200 smart home data set for the root mean squared error, we also find that the error was really, really low. And of course, the R squared was really, really close to 1, which is something that one would need to see. When we compare ANN across all the various data sets to the LSTM, we definitely do see, in the instance of the 20 smart home as an example, ANN outperforms LSTM. And then in terms of MAE and then RMSE. It also does outperform when it comes to the 200 smart home data set as well. So it shows you how well ANN actually does perform with prediction when it comes to these data sets. When you compare ANN again to GRU, you definitely do see that even with a 20 smart home data set, it still outperforms GRU when it comes to the MAE, and then it also outperforms it drastically when it comes to the RMSE. However, GRU did, show, improvements when you got to like a 200, smart home data sets where the performance actually did outperform the 200 smart homes for LSTM. So in general, we see that as we are scaling, actually, when you look at it carefully, the one thing that the models all did very well with regards to scalability and prediction was that even though the R squared was actually going down for the LSTM and the GRU, it actually did when it comes to ANN, it actually was very, very stable in the prediction outcomes. And so we saw, RNN did well in terms of performing best overall when it came to predicting from 20 to 200 homes with a very stable and accurate as well as quick training. It also did show good performance. When it comes to LSTM, it was good performance, but we needed longer training times. GRU competitive, slightly higher errors in some cases. If you compare, as an example, the 100 smart homes to the LSTM, you can see that LSTM outperformed GRU by a large margin when it comes to the RMSE. So what we see clearly here is that ANN maintains consistency in accuracy with scale, which is something that one would like when you're looking at deploying your DL model at scale. However, LSTM and GRU,
Dear
whereas
presenter,
they scale if
can you just
sorry.
please conclude with your presentation as soon as possible?
Yes, thank you. I'm almost done. So whereas LSTM did that, you could see that it scales effectively, but the risk of overfitting remains very high. When we look at training time and inference, clearly the ANN also did really, really well when you look at the training times. So it trained really, really quickly as compared to the others. And then also with regards to the inference time, it was also, really, really much better. Now, we also looked at finally, what happens when you take, say, ANN, and then you increase the number of epochs versus time, and then the error for, the 200 smart home data set. And what we saw that the model time for ANN for 500, was, about 3.76 seconds. And, the error was also fairly stable across board. So you could see a very good prediction outcome for ANN as compared to most of the other two models that we use. The limitations of the work is that even though we did use synthetic data, it may not have captured the full complexity when it came to real world, data, and then also occupant behavior, and then the device. We also looked at regional specificity, which typically might not easily help when you have to transfer the model to other habitats. Also overfitting risks that were presented by some of the other models, and then computational constraints over there. Our key takeaways here is that ANN showed a robust and efficient, performance, particularly for larger data sets. So we are able to effectively scale. And scalability analysis does favor ANN in terms of training time and inference efficiency. With regards to future directions, we're looking at hybrid models where you look at ANN with regards to other interoperability. We know they are not as interoperable, sorry. And then also we want to look at, transfer learning to adapt models to new regions and climate, as I shared earlier on. Thank you very much.
Yes, sir. Thank you for the presentation. Any questions, sir?
Yeah, Mr. David.
Yes, sir.
Yeah, so what exactly the objective behind the work?
Yeah, so like I said, we wanted to understand, as with most data, as the data that is coming in for the smart home is increasing, how can we look at effectively predicting the consumption when you look at not just one home, but several homes, or maybe a smart city in general? And how can you effectively manage consumption in smart homes, in smart cities? Sorry, thank you.
So I think when we are considering about the smart home, sometimes we have the concept of the smart energy meters. So with the help of this kind of the smart energy meters, even you can retrieve the certain kind of the detail And second thing is that the whatever the I think at this moment you have considered the different models and the results you are getting. So the overall we can say the there is the values which we are getting, accuracy which we are getting, so they are nearly equal to in the different kinds of the models. So even I have seen the values of the R square which you have mentioned. So I think it looks like almost the same values in all the different models, right? So
Yes, so we,
okay,
yeah.
yeah. So what I would like to suggest is that if possible, you can identify some kind of the use case, as well as if possible, you can even consider the kind of the certain performance parameters, so that you can differentiate, and at the same time you can even identify the exact purpose, for what purpose actually you are doing your this research work.
Okay, thank you very much.
Thank you. Thank you, sir. Moving on further to the next presentation. We have our next presenter who would be presenting a paper on augmented reality and virtual reality in computing and engineering education, pedagogical integration hurdles, a systematic literature review. Emmanuel Freeman, yes, sir. Are you here?
Yes, please. Thank you very much. And
Yes, sir.
good afternoon. Good
Good afternoon,
evening,
sir.
irrespective
Can you
of
please?
wherever you find yourself.
Yes, sir.
Thank you. Okay.
Can you please share your screen?
Okay. I believe you can see my screen.
Yes, yes, sir.
Okay. Thank you very much. My name is Dr. Emmanuel Freeman from the University of South Africa. I'm here presenting on behalf of my team as the lead researcher on augmented reality and virtual reality in computing and engineering education, looking at the pedagogical integration hurdles. Major focus was only to perform the systematic literature review. Of course, this is an emerging research that we are performing. So hopefully on Friday, I'll present much more technical findings that emanated out of the technical research activities gathered throughout the training and development of our scientific models that enhances teaching and learning using augmented reality and virtual reality with specific interest in memory management in VR and AR systems. And I'm presenting with Prof. Ernest Nkandla, Dr. Latif, Lucilla, Siri, Ganesh. To begin with, I believe we are all much interested whenever we see things visualized, we are able to read meaning when we see things in a real world scenario where certain context needs to be put into a much more rationalized context. Most often we become so happy. But we notice that there have been a scientific gap in the training and in the teaching of computing and engineering education. And colleagues present here can agree with me that the evolution of the engineering and computing education has shifted towards a more practical and experiential learning. Why am I saying this? Gone were the days we would stand in class to teach students how to draw logic gates, how to develop a simple IoT platform, whatever, without necessarily seeing how those things really works in a typical confined environment. So when the student watches those videos or engage in those virtual environment, they're able to apply it in a real-time scenario. So there has been a shift. So the virtual reality and augmented reality have emerged as a transformative technologies for enhancing teaching and learning. Of course, despite their potential integration of AR and VR system into education, we notice that there is some significant pedagogical challenges in most parts of the world. So you notice that there's a global disruption. How? Because the traditional face-to-face education disrupted by COVID-19, which we are all much aware of, is leading to an increased digital learning adoption. And it is a formidable fact. A lot of higher education institutions have to go through all these hell of experience in order to get some significant learning experience for their students, especially for those in the engineering and computing fields. Of course, the business and then arts domain, it was easier because most of their concepts are very theoretical. But in our cases like engineering, medicine, computing, aeronautic engineering, name all those
Hello.
domain areas.
So sorry for the interruption, but you're still at the introduction page.
Yes, I'm summarizing this. This is a new slide.
Okay.
Thank you
Okay.
very much. Yes, so there is a global interruption. And then there are some challenges of online learning, which are mostly limited to the ability to teach complex models and hands-on subjects. There are also key areas of immersive computing technologies where AR and VR systems are seen as an autonomous solution to enhance online education, among other benefits that AR and VR provides. But then, what is our aim? What is our motivation? Why are we doing this research? You know, the combination of augmented reality and virtual reality is increasingly recognized as a viable teaching and learning approach. So there's a need for more engaging and immersive learning environments in these domain areas. So the study seeks to identify the integration barriers and propose potential solutions to this particular research. And the systematic research approach was used. So we dive into getting much deeper attention to know the emerging trends in the AR and VR as applied in computing and engineering education. So we noticed that key research areas like extended reality is one of the emerging areas. And when you talk of the extended reality, it's all about how AR and VR are mixed, and mixed realities are all included under the general term XL. And this integration is how these two major components fuse into a common platform to enhance augmentation or to enhance visualization, to enhance comprehensions and understanding. So this has come to stay with what we call the XL. Then we have what we call the immersive learning environment. Several studies have mentioned that, but particular in the area of immersive learning is how to develop immersive learning process using AR and VR being the critical call to experiential learning, creating instructional materials that surpasses conventional approaches and use lifelike simulations and scenarios to enhance how concepts are being, modeled or communicated. Enterprise adoption. This also uses an advanced AR and VR computations to visualize and train staff, students, or any whatever that is with critical attention of improving productivity and cutting expenses and boosting training results. There are areas in the geospatial information processes, the 5G integration, which most of us in advanced countries can attest that with a quicker data transfer and lower latency, it is made possible by 5G networks. And AR and VR apps can benefit in this domain. Applications in healthcare, application in marketing and cloud, AR has come to stay. And all these domain areas, as researched on, poses significant interest in the research dimensions of AR and VR. And to reiterate that the study seeks to identify the barriers in terms of the integration and its potential solutions. Now, let's see some of the i.e. the research methodology that was used. So the study employed a preferred reporting item for semantic literature review called a PRISMA, and we searched databases on Scopus, Web of Science, and IEEE with a total papers retrieved of about 512. The screening processes followed the filtering and eligibility of relevance. So, as seen in this figure, we got a total of 235 documents or research articles from IEEE, 156 from Scopus, and 121 from Web of Science. This totaling to 512. And total number of data, i.e. the document that was finally screened after removing duplicates and chapters reviews were removed, a total of 217. Then the title and abstract that were screened in total were 295. Then we removed some of the irrelevant ones to check for the eligibility and the most coherent one, a total of 139. And the 4 people that were totally screened after thereof is 156. So we excluded 98 thereof. Finally, the papers that we concentrated much of the attention on for in-depth review were 58. Several of these findings that emanated from the research will interest PMSCA to know that the VR and AR offers emerging and dynamic learning environment for engineering and computing students, and there has been no two ways about it. Why? Because this provides the inherent understanding and comprehension of most of the concepts theoretically presented in classes. We also notice that the benefit to which AR and VR provides to computing and engineering students enhances an effective comprehension level as deduced from the various researches with improved practical skills and interactive simulations. So there was no two ways about it that out of the critical findings that we discovered, the interactivity level, the practical level,
Sorry
the
for the
experiential nature.
interruption. Dear presenter, can you please conclude as soon as possible? We just have 2 minutes.
Very well. Thank you very much.
Thank
Then the critical challenge identified was the pedagogical integration, which has got to do with technical constraints and cost implications and faculty training. So the major issue for institutions striving for AR and VR integration in engineering and computing boils down to the technical constraints, to the pedagogical, the method to which the teaching and learning is developed, the initial cost of the implications, as well as the training. So these are the potential solutions that that emerged from the findings. So improved faculty training was seen as a critical area of interest from literature, so to say, that can enhance the hands-on experience of AR and VR. Curriculum design, embedding AR and VR-based learning activities in coursework was very critical. Institution must also support, as well as collaboration with industry. And these are practical solutions and remedies to the challenges that were identified from literature. And we noticed that there are implications from the findings, and practical of it has got to do with policy makers as well as educators. Here, policy makers are supposed to develop guidelines for the integration. Institutions should allocate resources for the AR and VR adoption. Educators must also embrace innovative teaching methods that leverage these technologies. And finally, we will be able to embrace this whole innovation. So in conclusion, VR and AR have the potential to revolutionize engineering and computing education. No two ways about it. And while the challenges exist, the systematic solutions as preferred can ensure its effective integration. Future research should also look at the long-term impact and optimization strategies, which in our next presentation, hopefully on Friday, we will explore the technical implication as it has been employed over a period of time. Thank you so much for your attention, and I hope colleagues can ask questions. Thank you very much.
Thank you, sir. Thank you. Any questions, sir?
So, Doctor, yeah, I would like to ask you one question regarding, of course, AR/VR is a emerging technology. It's a futuristic technology, but I would like to ask you, have you identified any the challenge which affects the implementation of the AR/VR technology in we can say in teaching learning?
Yes, you notice from the findings that it is clear that the challenges are predominantly three. Of course, a lot of institutions have started to procure some VR, you know, spectacles and VR machines, but the integration to the pedagogical integration has been a technical challenge. So they have those machines in most of these AR laboratories you go, but how do you integrate teaching of maybe electronics, teaching of IoT, teaching of programming, teaching of augmented or artificial intelligence into the VR space? So there have been that challenge. And number two is faculty adoption and acceptance. Most of them are not trained. Of course, these are futuristic technologies, these are emerging technologies, and a lot of people are not even aware how it works. Then the cost implication that comes with it. So these are the major challenges that were identified in research. Post this particular research, we try to implement it with a certain set of students, and the findings will blow your attention. I don't want to go much deeper into the modeling bit of how a piece of data was placed on VR AR machine and how it performed. But in all, the pedagogical integration, the cost of implementing it, and the faculty adoption and training are the major challenges of its implementation. Thank you very
So
much.
right. So the as you mentioned, one of the key challenge it is about the cost factor, and second the even I'm working with this AR/VR technology, and even we have tried to the set up a kind of the lab, but one of the major challenge which I have experienced, it is related to the we can say content development, right? So if you do not have the sufficient contents, if you have not they develop the sufficient contents, so again it will be difficult to even we
That
can
is
say
true.
implement this AR/VR technology.
Data
So
and
whatever the contents we have, so they are not we can say in the form we can even visualize in a three-dimensional way, and even they are not in the appropriate form we can directly upload in this kind of the AR/VR kind of the devices or like that, right? So
Very
yeah,
true.
so there is a need that we require to think in this direction to make this technology we can say more beneficial to the teaching learning domain. Yeah, thank you.
Very well. Thank you very much. And that is very important, especially when it comes to the pedagogical integration of the content, the specific content in the delivery. And this is very important towards the
Thank
entire
you.
revolutionization
Thank
agenda
you.
of AR/VR. Thank you very much.
Thank you. Thank you.
Thank
We have
you.
our next presenter with us who would be presenting a paper on data envelopment analysis approach for smart city performance evaluation. Yes, ma'am. Mehtab Darsan.
Hello,
Yes, ma'am.
I share my screen.
Yes, please.
You can see, I think.
Yes, I can see your screen.
Okay, thank you. Hello, everyone. I will present you the study data development analysis approach for smart city performance evaluation. I'm associated professor at Galatasaray University, and I prepared this research with my colleagues Mertinal and Nazlı Göker. First of all, I will briefly introduce the subject, and then I will explain data analysis. After that, smart city performance will be evaluated using data development analysis, and finally, concluding remarks will be provided. Significant increase in urbanization poses serious challenge in the allocation and utilization of the already limited resources on Earth. As migration from rural to urban areas and intensifies and cities expand, energy and water consumption rise, air quality deteriorates, and the demand for essential services such as sanitation, infrastructure, and transportation grows. Addressing the challenge posed by growing urban population while ensuring a better quality of life for citizens has become the responsibility of local and national governments. And at this point, smart city initiatives play a critical role. Public leaders through proper planning and investment can transform cities into more livable, more workable, and more sustainable space, both economically and also environmentally. Smart cities are city concepts that aim to optimize the infrastructure, service, and quality of life of cities using information and communication technologies and the Internet of Things. And smart cities aim to create more sustainable, efficient, and livable cities by integrating technologies in the areas such as energy transportation, water management, public service, and security. For this reason, researchers conduct many research on smart city evaluation, and some researchers provide some indices for measuring the smartness of the cities. As you see here in figure 1, this is the co-occurrence overlay visualization based on outer keywords of research on smart city ranking. As you see here, smart city is linked with quality of life, sustainability, economy, smart sustainable cities, and also open data. So this is an important research area for researchers. And as I mentioned, recent studies focus on developing a smart city index for measuring the smartness of the cities. And at that point, International Institute for Management Development, IMD, provides smart city index at each year. The IMD Smart City Index 2024 evaluates citizens' options about the structure and technological applications that are available to them in each city. And citizens' options are thought on two pillars. The first one is structural pillar, and the second one is the technological pillar. Here, structural pillar refers to the city's current infrastructure, and technological pillar describe the technological service and amenities that the citizens can access. But the IMD's rank smart city index rankings is based on 120 locals, and they obtain the final scores by employing the perceptions of the last 3 years with the weights of 3 to 1 for 2023, 2022, this is normally, and 2021. This is, as you see, this is a weighted average normally. moving weighted average method, forecasting method. And here, the aim of this study is to provide more technical ranking in these indexes for the cities, and for these purposes, we employed data analysis to measure the performance of each country regarding each pillar here, and also we compared the results. Normally, the basic data analysis, the original data analysis model is proposed by Charles, Cooper, and Rhodes, and this model is called as CCR model. It computes the relative efficiencies of a decision-making unit, here cities, by maximizing the ratio of its total weighted outputs to its total weighted inputs, subject to the condition that the output to input ratio of every decision-making unit be less than or equal to unity. Here in equation 1, you see the CCR model. As you see, this is a nonlinear model. So Charles, Cooper, and Rose transformed this model to linear model, as in equation 2. This is the linear version that is more computational efficient. The CCR model decommodizes the decision-making units as efficient and inefficient. Thus, it assigns one as efficient score to the decision-making units. However, it considers inefficient decision-making units possessing efficiency score less than 1. Hence, CCR model provides neither a powerful discrimination discrimination amongst decision-making units nor the realistic weight distribution. Thus, many other DEA models was proposed in the literature that wants to increase the discrimination power of classical CCR model. One of them is Tolo's model, and Tolo contributed to the common weight multi-criteria decision-making DEA by proposing a novel mixed integer programming model with enough discrimination power to determine the best efficient decision-making units. And this model can give a full ranking of the decision-making units. Here, the Tolo's model has two phases. In the first phase, we use equation 1 to find the epsilon value. This is the non-Archimedean infinitesimal epsilon value. We find here the epsilon value, and then we use this epsilon value in equation 2 to minimize the deviation. D here in this equation you see D max. This is the maximum deviation from efficiency value. So here in equation 2, we try to minimize maximum deviations from the efficiency value. So by using equation 1 and equation 2, it's possible to obtain full ranking of alternatives here. In this study, we employed we try to find the performance values of top 15 cities according to IMD Smart City Index in 2024. The evaluation criteria are determined as health and safety, mobility, activities, opportunities, and governance, and the performance of each city is calculated for structural pillar and technological pillar separately. Thus, we have two rankings. We obtained two rankings for each city. Here, if you you can see the explications of the pillars of the criteria, evaluation criteria. You can also refer to the proceeding to see the details of these criteria. And here in table 2, you see the data of 15.
Hello.
Sorry?
Yeah. Can you please conclude with the presentation?
Okay. Here In table 2, you see the data of cities according to a structured pillar, and in table 3, data of cities according to technological pillars, and we employed the VEA model for these two pillars. Here in table 4, you can see the full ranking of the alternatives considering technological pillars, and here in table 5, it gives us the full ranking of these considering structural pillars. Then we compared, according to the results, Beijing is ranked first, which is followed by Abu Dhabi and Dubai considering technological pillars, and Hamburg ranked last. When we consider the structural pillars, Abu Dhabi is ranked first, which is followed by Dubai and Zurich, and also we find the correlations among these two rankings. The correlation score is found at 0.66. This result shows that cities' current infrastructure and technological service and amenities are different. So thank you very much for your attention. That's the end of my presentation.
Thank you. Thank you so much. Any questions, sir?
No.
Okay, sir. Thank you.
Thank you.
Thank you. Thank you, ma'am. Okay, moving on further. We have our next presenter.
Hello.
Yes, sir. You are presenting a paper on evaluation of digital technologies for smart cities with fuzzy MCDM methods.
Hello again.
Yes, sir, you can start sharing your
I-
screen.
I can share my screen because it says that you cannot share, just the manager of that can share it.
No, you have to stop first, I
Just a
think.
minute, just a minute. Yes, sir,
Yes.
you can share your screen now.
Yeah, okay, I am. Can you see it right now?
Yes, yes.
Hello again. I am Mert Ünal. I'm a PhD student and I am currently working at Galatasaray University as a research assistant. I am also an industrial engineer. Today, I will share my article that I wrote with my two colleagues, Esim Mukul and Mehtap Tursun. Our article is about evaluation of digital technologies in the concept of smart city. To do the evaluation, fuzzy MCDM methods are used. First of all, I will briefly go over with an introduction about smart city and its solutions and multi-criteria decision-making, MCDM. Then I will show you our research methodology. After this, we will see two methods and its application. Lastly, I will conclude, then take the questions. So, the growth in urban populations increases the pressure on the already constrained resources of cities. As urbanization progresses, there is a notable rise in the demand for essential infrastructure services such as energy, water supply, communication systems, transportation, and air quality management. Furthermore, the requirement for vital public services, including education and healthcare, rises. Successfully tackling these issues necessitates significant financial contributions from both national governments and local administrations. However, urbanization challenges need to be addressed not only through large-scale physical investments, but also through smart solutions that involve creativity, human capital, and collaboration. The ICT offers more practical solutions to various challenges in urban areas. Managers should create smart solutions by using limited resources and leveraging technology to solve these problems caused by urbanization and develop the quality of life. At this stage, solutions brought by smart city applications are important to achieve more livable cities. In the literature, studies are being conducted on the use of technology in smart cities. For example, Zhao et al. Presented an application of smart city construction in a new data environment and analyzed the development of current status of big data in city planning. Wei proposed an application of IoT technology in the process of building a smart city. Cook et al. Discussed ICTs in the healthcare sector. So digital technologies play a pivotal role in the development and functioning of smart cities, enhancing urban living through the integration of connected systems and data-driven solutions. IoT devices and sensors enable real-time monitoring of essential services like traffic flow, energy consumption, waste management, etc. In this context, the evaluation of digital technologies for smart cities represents a standard MCDM challenge. This assessment entails a complex framework that includes a variety of criteria, which are frequently diverse and sometimes contradictory. The difficulty of selecting and prioritizing alternatives increases when the data is imprecise. So decision makers frequently struggle to convey their preferences in exact numerical terms. By employing fuzzy numbers, decision makers can express their perspectives more effectively, which helps reduce the uncertainty inherent in this fuzzy MCDM approach. This research focuses on evaluating digital technologies for smart cities using fuzzy MCDM methods. The proposed evaluation model is built on insights gathered from a comprehensive literature review, industry reports, and consultations with experts. The study employs fuzzy simple additive weighting method to determine the relative importance of the evaluation criteria, and also it utilizes fuzzy Kopras method to assess the digital technologies applicable to smart cities. In the evaluation framework, 3 main criteria and 12 sub-criteria have been established through a thorough review of existing literature. This table illustrates the framework. It offers a detailed structure for assessing smart city technologies by organizing the criteria into 3 main categories: technological, conceptual, and infrastructural. Each of these categories is further divided into specific sub-criteria, thereby creating a comprehensive approach to evaluating the various dimensions of smart cities. Decision makers can analyze main and sub-criteria using linguistic variables, which can be seen from the first table with orange one. Now, let's see the second table. For example, the first decision maker, DM1, if you can see the first column, DM1 thinks that C11 is an important criterion in the concept of smart cities. That's why he or she used very high VH, but also he or she used very low VL for C34. This indicates that the first decision maker considers C34 criteria 34 to be less important than C11. Fuzzy solve steps are applied, and we obtain criteria weights, which can be seen from the third table. Fuzzy Kopras, proposed by Zavaskas et al. This technique ranks alternatives based on priority and utility. It's also a distance-based method. Experts utilize the linguistic words indicated in the first table to evaluate the options. In this study, there are 4 options, such as IoT, big data, AI, and cloud computing. The DMs made an evaluation between criteria and alternatives using linguistic words. Let's look at the second table. For instance, decision makers think that the first alternative and fourth criterion has an absolutely more important relationship than steps of fuzzy Kopras have been applied. as a result of evaluating digital technologies using the fuzzy copras method, here the best alternative for smart cities was identified as big data. IoT is the second. AI is the third best option. So, to conclude, in this regard, assessing digital technologies for smart cities presents a typical MCDM problem. However, when dealing with imprecise data, selecting and prioritizing options becomes challenging. DMs struggle to convey their preferences in exact numerical terms. That's why they are using fuzzy numbers. This research focuses on assessing digital technologies for smart cities by using fuzzy MCDM approach. The evaluation of digital technologies using the fuzzy copras method identified big data as the most suitable technology for smart cities. The problem can be addressed by employing various fuzzy MCDM methods for future directions. Thank you.
Good day to you and good day to you, the chair of the session. Could you please confirm if my slide is?
Yes, your slides are visible, sir.
Okay. My name is Latif Akiamin. I'll be presenting a paper titled "The Improving Heart Disease Detection with Data Analysis from the Perspective of Machine and Deep Learning Perspective." So here are the outline of the presentation: introduction, motivation, problem statement, literature review, method, numerical, key findings, and conclusion. Here, the introduction. It is known that the heart disease is prevalent and potentially fatal disorder that affect greatly the percentage of global population in this recent time. Based on the CDC control, it continues to be one of the human factors that accounted for a lot of death in recent times. So machine learning methods are generally important in different areas of human endeavors, including visual and text classification. More so, deep learning, on the other hand, entails the application of neural networks with many layers to examine and translate complex trends and patterns in data. So, heart disease is generally known as a silent killer, which often miss early signs. That is, discover how machine learning and deep learning unlock hidden biomarkers. So, harnessing big data for early detection, it is expected that a massive data set and artificial intelligence algorithm will reveal a software and predict fake data patterns. Personalized risk stratification in real time, time series clinical data, dynamic and patient heart disease also can be predicted as well. Proving across diverse population, external validation in Korean and European cohorts have demonstrated robust and real-world performance and paving the way for the proactive care. So this is a kind of a schematic diagram of the present study, collecting medical symptoms, age, cholesterol level, blood pressure, and those pieces of data will be fed in as input and into the machine learning this, and output. From the output, they will now see how the disease is it positive or negative. So behind that, there's a motivation behind this, and heart disease remains the leading cause of death globally. But early detection continues to be a major clinical challenge. Conventional diagnostic schemes often miss an early biomarker that could result in cardiac issues. So advancement in machine learning and deep learning could offer powerful tools to analyze and examine the complex nature of this ailment, a series of data with unprecedented precision. By interacting the diverse data set from electrocardiograms to longitudinal clinical record via the spiral models, it can personalize the risk assessment and improve prognostic accuracy in this regard. So, improved detection not only enables timely intervention, but also has a great potential to reduce the risk, health cost and save lives by preventing advanced heart disease. The problem statement is heart disease remains the leading global cause of death, yet its early detection is hampered by subtle, complex biometric reading in noisy, high-dimensional clinical data. So standard diagnostic and statistical schemes fail to capture the dynamism and changes the patient's risk profile, thereby limiting timely intervention and efficient treatment. Hence, there's an urgent need for this advanced machine and deep learning to be employed in this regard. So we review some of the literature review in which heart disease has been stated to be a life-threatening condition, responsible for approximately 18.2 million deaths annually. So early detection and diagnosis are important for effective treatment and prevention. But in developing countries, such as in Africa, the complexity of heart disease detection and diagnosis is worsened by the lack of efficient diagnosis tools, medical professionals, and other resources, leading to delays in patient care. Furthermore, this study employ an automated decision support system based on machine learning to address these challenges of overachieving and thereby achieving an accuracy of 93%. So, also in the works of 1920 and up to 22, CNN-based method has been used, and using the data set for concerning coronary heart disease and electrocardiogram signal analysis were utilized and analyzed accordingly. Additionally, several machine learning algorithms and deep learning schemes are utilized to address diseases ranging from chronic kidney disease disorder to SAM. In one of our previous work, we have addressed some of this. And the topic of the heart really has not been thoroughly investigated, though the driving force for this current study attempt to close the gap between the use of machine learning and deep learning. So the method employed in this study is the data collection, go through the data analysis, data splitting, model building, training, model testing, prediction, the model evaluation. Under the data collection, data analysis, we have feature encoding, relationship between the attribute and feature importance. These are called feature engineering in a nutshell. So we continue with, so after the data collection, move to the data analysis, feature encoding, feature importance. This is done to select essential features for the module. So here now, this is a kind of training course of the essential features and implementation procedure of method employed. So here now we employ some of the features, EKG results, chest pain type, BPH, and etc. And on the right hand side, that is the implementation procedure. So we examine the relationship between the attributes. This is done using the cage plot to demonstrate connection between the input and output, and relationship between age, cholesterol, and turnover of the target output. Easy. So under the numerical result, we fed in we run the loss against the epoch, and we have the trainings under the training. The data set is divided into training, which happens to be the 70% of the, and the testing happens to be 30% of the data set. So we apply some of the machine learning and deep learning algorithm, the DNN, deep learning, decision tree, random forest, night bias, and logistic regression. And it is can be far from the figure now that the deep learning and kind of a random forest do perform in terms of the accuracy. Then in some other using other performance metrics, they do not perform. But essentially, in terms of sensitivity, accuracy, and precision, DNN and random forest do perform on other techniques. This figure 10 and 11 and 12, 13 demonstrate the confusion matrix to know the true positive and true negative of it. So we employ the table one is parameters of the confusion matrix, where we are applying the DNA, RFDT, linear regression, naive bias, and this using the equations 1 to 4 for the table. So here now on the figure 4 shows the visualization of the evaluation matrix employed in this regard. So like I did say in my previous slide that DNN and reinforcement learning outperform other techniques in terms of precision and accuracy and sensitivity and F measure. So interpretation of the result is that the performance of 6 classifiers, namely DNN, is assessed employing 4 primary metrics: accuracy, precision, sensitivity, and F measure. So The result are presented as Bashar. The DNA stands out as part in terms of precision, sensitivity, and efficiency, given a value of a numerical value of 90.03, 87.14, and 88.00 respectively. This indicates its effectiveness in tasks where accuracy is crucial, as it were, and it can detect true positive while minimizing the false positive. Among the classifiers, the random forest achieved the highest accuracy and precision, suggesting its robustness in correctly classifying most cases, like the DNA, as it came. So its high precision further emphasizes its capability to reduce false positive with a reliable source for task requiring accuracy and precision. Meanwhile, both RF and DNN performances exceed the other modules, as I've pointed out in the table previously. This observed stability nevertheless could suggest a likelihood in the visibility of near overfitting or less robust generalization ability, leading to a reduced.
Dear presenter,
Yeah,
can you please conclude with
okay,
your presentation as soon as possible?
okay, thank you. So the key find is that random forest and deep learning was consistently achieve higher overall predictive accuracy and with a under curve where both RF and DNA effectively capture the complex non-linear relationship in high-dimensional clinical data, leading to improved risk stratification. So in conclusion, this study shows that the advanced ML techniques, particularly DNN and RF, significantly outperform the conventional models like decision tree, by sort of early detection. So DNN and RF excel at capturing the complexity in the non-linearity trend and handling a noise high-dimensional clinical data, leading to more accurate prediction. These superior modules offer the promise of personalized and assessment and intervention, which can ultimately reduce the mortality and healthcare costs. So, the call to action is clinicians and researchers and policymakers should collaborate by integrating these advanced AI tools into routine cardiac care to revolutionize health disease training and improve patient outcomes. So, these are some of the references we use in this study. Thank you.
Thank you, sir. Thank you for the presentation. Sir, any questions?
Yeah, I would like to ask one question. It is regarding you have mentioned in the last statement in the conclusion. So have you consulted any the healthcare professional regarding what is the opinion views regarding this application of the AI/ML, especially for this disease detection?
Thank you, Disha. Yeah. In our current study, because we just use this as a benchmark. So in our future study, we have contacted some of the health professionals. In the first, at the initial stage, some of them were not willing to give us an audience, but we've secured two health practitioners institute that have given us a audience. In our future study, we intend to discuss the implication of AI tools to their practice. So moving forward.
Moving on further, we have our next presenter who would be presenting the paper on IoT-powered pest management system for tomato plants, effects of various light spectrum. Yes, sir.
Everyone.
Mohammed Hassan.
Hello.
Yes, sir. Hi.
I'll
Can you
be
please
sharing my
start sharing your screen, please?
share. Can you see my slides?
Yeah.
Okay. Hello everyone. My name is Ahmad Ashir. I'm from the University of Brunei Darussalam. Today I'm going to present about my paper, IoT powered pest management system for tomato plants, effects of various light spectrum.
Yes,
So we
yes,
will
I
move
can
on
hear
to.
you. You can start.
Okay, we will start with the introduction. Wait. No. Okay. Food security is a growing concern due to rising population, climate change, and supply chains, as we all know. To combat this, IoT technologies can help to enhance crop management by enabling real-time monitoring of plants factors such as temperature, soil moisture, and light. This is particularly focused on tomatoes, as it is required a precision agriculture and data-driven farming to improve crop production, efficiency, and yield. So tomatoes, as also known as Solanum lycopersicum, are widely grown and consumed for their culinary versatility and benefits. In Brunei, where I am from, we import around 673,566 kilo, which are equivalent to Brunei dollar 1.7 million in 2023. As you can imagine, we Bruneian we like to eat tomatoes. But to produce our own tomatoes, we are faced with a few challenges, including tropical climate issues, pest control difficulties, limited land as our country is quite small, and poor soil quality as our soil contain a lot of clay. So in the paper, we provide a potential solution for tomato production in Brunei, which is with the use of controlled agricultural system using specific light environment, in this case LED lighting, that can enhance tomato growth and yield. As a added note, it can also deter pests, which reduce the reliance on pesticides. Integrating this system with IoT technology can offer a sustainable solution to improve tomato cultivation in Brunei. The aim of the paper is to assess the influence of various light environments on pest attractions and their subsequent effects on plant health and growth. By identifying the wavelength most attractive to pests, it can help to enhance the understanding of pest behavior and in its impact on plant characteristics, such as chlorophyll production, nutrient intakes, and morphological integrity of the plant itself. So this is our setup. As you can see here, we have 3 stations, which each station have their own LED lighting, which are red, green, and violet. So the reasoning for those colors are: red represent the longest wavelength, green represent the mid-range wavelength, and violet represent the shortest wavelength. As you can see in the center of the 3 station, there is a pest-infested plant source, which are positioned about 1 meter away from each station. The reason for 1 meter is to reduce the effect of lighting that can mix between each station. So each station will have their own 4 potted plants for samples, and the system are run for 14 days period. So these are the IoT components. For the focus of this research is for affordability, as for easier deployment to real world environment. So we focus on cheap and affordable system. In the system we are using Arduino Uno and not MCU. So Arduino Uno is a microcontroller, while not MCU is also a microcontroller, but it can have the ability to transmit data through Wi-Fi to a cloud storage. So the sensor we use for the setup is soil moisture sensor, pH sensor, NPK sensor, which is the nitrogen, phosphorus, and potassium, which will be the nutrient measurement in the soil, and a relay. The relay will be powering the light supply to simulate the day and night cycle. So as we are transmitting the data to a cloud storage, which in our case we are using a Microsoft Excel sheet, we did and we did 10 data points to ensure data accuracy and minimize error. As in those 10 data points, we average it into one point of value to minimize any spiking or invalid data. So for the chlorophyll measurement, we use a CCM 200 plus leaf chlorophyll meter from Apogee instrument made in the USA. And the data are collected for the chlorophyll of a plant at 3 different height levels: at the lowest, at the middle, and the highest point. So we move on to the results. For station 1, we observed that moderate chlorophyll increase between all the pots, and then the pest count, only about 4 to 7 pests, did not show a clear effect on chlorophyll levels. So for station 2, the green light station has the highest total pest counts, especially in pot number 1, which are 10 pests, and pot number 2, which are 7 pests. So interesting note on one pot, especially G1, we call it in G1 in station green 1. It has the chlorophyll measurement increased drastically, especially towards the end of the period, which on the 14th day, despite high PES, while G3 dropped drastically in measurement despite only having 5 PES. So upon further inspection, we found out that the plant itself on the soil has been infested with mold. So we conclude that that has affected the health plant drastically. In station 3, violet, we found out that it has the lowest PES count, leading to a stable chlorophyll level throughout the 14 days. So, on the nutrient intake measurement, we only focus on the potassium reading, as the other two are linearly decreasing throughout the 14 days period, which is expected because the plant take up more nutrient. So potassium uptake for the red and violet light significantly increase as the days goes by, suggesting their role in enhancing nutrient absorption during flowering and fruiting stage. As noted before, the green light attracted the most pests, while violet attracted the least amount of pests. The pests we mostly encountered with aphids, and we consulted with our biologists in our university, and as to why this is happening, they give an hypothesis on the pest itself cannot see that much light under violet light, reducing their ability to detect host plant, while in green light, uh, it is easier for them to detect the healthy tomato plants. So in conclusion, yeah, green light in fact attracted the most pests. Red and violet light enhanced potassium uptake. The IoT system itself are able to provide real-time monitoring, aiding in precision agriculture. But as the system is ran in a controlled environment, it limits the real world factors such as weather, wind, or natural local pests that are other than aphids were not considered in this system. So for future research, we would like to implement a long-term effect of plant environment on plant growth and pest behavior, and also pest characterization under different light condition to analyze infestation pattern and plant resistance. By doing the study in open environment, it can help to have a more realistic assessment of pest dynamics, and ultimately the findings will aid in optimizing light condition as part of integrated pest management, promoting sustainable agriculture. Lastly, we like to acknowledge CREAS, the Council for Research and Advancement of Technology and Science under the university project, the Faculty of Integrated Technology and Faculty of Science, University of Brunei Darussalam, Department of Agriculture and Agri-Food, Ministry of Primary Resource and Tourism, and lastly, the Brunei Government Scholarship for the support they have given for this research. Thank you. That's all from me.
Thank you. Thank you for your presentation. Any questions, sir?
No. So you have applied this so you have this kind of the setup, right?
Yes.
So have you applied this setup in a real environment, or it is just
Currently,
the experimental work at the lab level?
Currently in lab environment, but we will like to implement it real world with the help of solar panels. So it will be totally off grid from any power outlet. But currently it's still in the setup phase, so maybe in the future.
Okay, and you are mostly using the sensors which you have mentioned, that is the for we can say just to moisture detection
Soil
purpose.
moisture. Yeah.
Yeah. Okay. Thank you.
All right. Thank you. Thank you so much. Any other question?
Thank you. All right. Thank you, sir. Thank you so much. Thank you for all the presentation. Okay. All right. Just a minute.
Thank you so much.
Thank you. So we have come to the end of the session. I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this conference was informative enough. We, on behalf of the whole team, thank you for the support during this 10th version of the conference and all the previous 9th versions as well. We will be happy to have you in the 11th version in 2026. All the presenters would be getting their digital certificates through email within 2 working days. Already, all the papers have been forwarded to the Springer board and the publication will be live within 6 months. So please kindly cooperate with the team of ICICT. I also thank our session chair, Professor Kirit J. Modi. Thank you so much, sir, for chairing the session. This is a talk of appreciation from the team of ICICT and Global Knowledge Research Foundation and the partners. Thank you so much, sir.
Thank you.
Thank you.
Yes, thank you everyone. I have a small request. I request all the participants to turn on their cameras for a quick snapshot, please. All right. Thank you so much, everyone. Thank you. Stay safe. Take care. Bye-bye.